Let's assume that the world population is currently around 7.9 billion people, and that each person needs an average of 2,500 calories per day to maintain a healthy diet. We can use the following equation to estimate the amount of farmland needed to produce enough food to feed the world population. Total farmland = total calories needed per day x 365 days per year x 1.1. Average yield per acre x harvest index x crop calories per pound, where total calories needed per day = 7.9 billion x 2,500 calories per day = 19.75 trillion calories per day. 1.1 is a factor to account for potential food waste and losses during processing and transportation. Average yield per acre is the average amount of crop produced per acre of land. Harvest index is the ratio of edible crop yield to total crop yield. Crop calories per pound is the number of calories per pound of the crop produced. Assuming the following values: average yield per acre 2.5 tons, 5,000 pounds. Harvest index 0.5. 50% of the total crop yield is edible. Crop calories per pound 1,500 calories per pound for wheat, grain and legumes, and 200 calories per pound for vegetables. We can calculate the total farmland needed as follows. Total farmland = 19.75 trillion x 365 x 1.1. 2.5 x 5,000 x 0.5 x 1,500 plus 2.5 x 5,000 x 0.5 x 1,500 plus 2.5 x 5,000 x 0.5 x 1,500 plus 2.5 x 5,000 x 0.5 x 200. Total farmland = 3.5 billion acres. Therefore, we would need approximately 3.5 billion acres of farmland to produce enough wheat, grain, legumes, and vegetables to feed the world population. This is a rough estimate and does not take into account factors such as crop rotation, soil quality, and climate variability, which can affect crop yields and land use. There are approximately 4.6 billion acres of farmland in the world today. The countries with the most farmland are as follows: 1. United States 174.5 million hectares. 2. India 159.7 million hectares. 3. China 152.4 million hectares. 4. Russia 123.5 million hectares. 5. Brazil 79.7 million hectares. There are several innovative approaches being explored to create more farmland. 1. Vertical farming. This involves growing crops in vertically stacked layers, often in urban environments or indoor structures. It maximizes land use efficiency and reduces water consumption. 1. Aquaponics. This is a combination of aquaculture, fish farming, and hydroponics, growing plants without soil. It creates a symbiotic relationship where fish waste provides nutrients for plants and the plants filter the water for the fish. 1. Hydroponics. This method of growing plants in nutrient-rich water without soil allows for year-round cultivation and higher crop yields. 1. Rooftop farming. Utilizing rooftops of buildings for farming can help make use of unused space in urban areas and promote local food production. 2. Precision agriculture. This involves using technology like drones, sensors, and data analytics to optimize farming practices, including irrigation, fertilizer application, and pest management. It helps increase productivity while minimizing resource use. These avant-garde methods aim to maximize productivity, minimize land use, and reduce environmental impacts in the face of increasing food demand and limited arable land availability.